Hello, everybody. So we're going to start here with Chapter 4 lecture. Aqueous solutions. So first of all, what is a solution? A solution is a homogeneous mixture made up of a solute and a solvent. And the solute is the substance being dissolved, and the solvent is the substance doing the dissolving. So salt in water. Salt is a solute, water is a solvent. So when we talk about solutes, we talk about them as electrolytes or non-electrolytes. So an electrolyte is anything that breaks up into ions, such as an ionic compound, a metal and a non-metal as a compound. And then non-electrolytes are molecules, molecular compounds, or we refer to them as covalent compounds containing two nonmetals. So a strong electrolyte is something like sodium chloride, NaCl solid. When placed in water, it breaks up completely into the two separate ions of sodium positive 1, chloride negative 1. And then a weak electrolyte is something like a weak acid, such as acetic acid. Acetic acid breaks up, but not 100%. So it ionizes only partially. So when we have our solution of a weak acid such as this, our solution contains hydrogen ions, acetate ions, and some amount of the molecular form of the weak acid. That's why we showed two arrows here. Gen Chem 2, second semester of this course, we'll talk a lot about equilibrium. That's what those two arrows indicate. You don't have to really worry about it now. And then we have non-electrolytes, something like methyl alcohol as a liquid when placed in water just becomes that whole molecule, the methyl alcohol molecule, as dissolved in water, AQ. That's what your state symbol means there. AQ means it's in water. Liquid means that it's just a pure liquid. So when we think about electrolytes versus non-electrolytes, when we talk about double replacement reactions, which we talked about in the last chapter, in a double replacement reaction, a precipitate forms. So it has a couple different names: an exchange reaction or a metathesis reaction. I always refer to them as double replacement reactions, but they're all the same. So let's say we have something like this: lead nitrate, aqueous solution, potassium iodide, aqueous solution, and these are the two possible products. We would call this, kind of the normal double replacement reaction, the molecular equation. In fact, I have a short little video of this reaction posted in the helpful video links that I always post. So then we would take this equation and break it up into its ions. And so all I do is separate it by each of its ions, the Pb positive 2, the two NO3s, then the potassium ions, the iodide ions. And then I'm going to leave this together as the precipitate, and I give it an S as its state symbol. And then the other two ions that exist, the other two types of ions, are just going to be called the spectator ions. And so how do I know that lead iodide is the precipitate and that I would keep it together like that? Well, I would refer to the solubility table on page 127. I've also posted a chart in the course content that tells you what substances precipitate, what ions, when in the presence of each other, will form a compound. And so that's how we know that the double replacement reaction actually occurred. So you should look at the short little video. I think it's a 1-minute video that shows that reaction. So then I want to be able to break it down to its net ionic equation. And the net ionic equation, by definition, is shows the ions that form the precipitate, and that's it. So there's the two ions that form the precipitate, Pb positive 2, iodide negative 1, two of them, forming PbI2. And so note the state symbols, AQ for the ions in solution, and then solid for the precipitate. Then I showed one here where we would say no reaction occurs, because here I have the lead nitrate, here I have potassium acetate. This I'm going to say no reaction occurs, because these would be my two possible precipitates that would form. This would be considered my molecular equation, like the first one I did above. And just based on this molecular equation, I know I wouldn't have to go any further to show a net ionic equation like this one, because no precipitate forms. If no precipitate forms, then there's really no reaction that occurs, because all I really have are these ions floating around these ions. And now they're still just floating around. I've shown them together because this is the molecular equation. But the ionic equation would look something like this one up here, but there would be no precipitate as I have in this one. I'm going to stop there.